Hey folks, in this video, I'm going to be talking about a very popular form of attack called front running. It's really more of a glitch than an attack, I would say. And this terminology, front running, is not specific to just security contracts. It's a popular terminology coined originally for traditional financial markets. What does front running mean, right? It's basically your race to order the chaos to the winner's benefit, right? So how can you translate this in your traditional sort of solidity ecosystem, right? It's the same way as the flow of information, right? This gave birth to intermediaries in the financial markets who could profit by being the first to know and react to some information. Similarly, in the solidity world, your transactions are known for a very short period of time to sit in something called mempool, right? Memory pool. How do transactions get accumulated in the form of blocks? You get a set of transactions, you put them in the blocks, right? And then these blocks get committed to the blockchain. So there is a very brief period of time where these transactions are sitting in the mempool and are available to view. Now, in this case, what you can do is that as an attacker, you can watch the transaction pool and send a transaction have it included in a block before the original transaction. So you see an original transaction, for example, you see a swap happening on the deck for something, right? So you see that it's a huge transaction and you see that it's probably going to give you an advantage if you do that swap before, that transaction actually happens. So you manipulate this the transaction order in such a way that you reorder the transactions to your advantage as an attacker. Let's see a quick example of how this can potentially affect the code that you can write in Solidity, right? Now, this is a popular guessing game. This is an exercise that's also available on Ethernaut. I will suggest to go through Ethernaut whenever you have some free time. It's one of the best sort of websites for you to understand the best practices when it comes to security. It has a lot of puzzles. So this is a guessing game where Alice has created this. You win 10 ether if you can find the correct string that hashes to the target hash. Let's see how this contract is vulnerable to front running, right? Let's take a quick look at the contract. Your contract is called find this hash. You have a hash that is already available, okay? And then you have a constructor. What you need to solve for is the solution is basically you need to solve for the hash. You need to solve for the correct string that hashes to this, right? And then once you got that right, what is the string? You got that right, the solution right. You get 10 ether, right? Very cool. But how can you front run this, right? Let's say that this contract is deployed with 10 ether in it, right? It has 10 ether already. Now, what will happen is Bob finds the correct string that will hash to the target hash. So Bob calls this function solve with the string, say Ethereum, right, with certain amount of gas price that Bob thinks is enough to get the transaction through. Now, Eve is the third party, the attacker, who is watching the transaction pool for the answer to be submitted. Eve sees that the answer that Bob submitted is Ethereum, and Eve submits the same transaction with a higher gas price. Now, as we know how the network works, right? If you submit the same transaction at the same instant, the one that's having a higher gas price will be mined. Miners are going to pick this, right? So miners will pick the transaction with a higher gas price, which will be mined before Bob's transaction. Now, Eve won the reward of 10 ether. What is happening here is that transactions take some time before they are mined, and whichever are not yet mined are put in the transaction pool. I'm sure as you might be dealing with MetaMask doing some transactions, you might see that something is still pending. That means it's still in the transaction pool. An attacker can get the answer from the transaction pool, send a transaction with a higher gas price so that their transaction will be included in a block before the original. Of course, since Ethereum has moved from proof of stake to from proof of work to proof of stake. The concept of mining is no longer valid. However, front running is still possible if you are thinking that you can manipulate or reorder the transactions, because the validators who are going to validate the blocks, they are still going to be looking at gas fees, right? Even though they are not miners who are picking the blocks, who have the ability to pick the blocks, the way your transactions are going to be ordered, it would still matter in the transaction pool. Therefore, front running is very much still an attack that is possible. There, to solve this vulnerability, they ideally try to send gas fee, which is most like in the average, so your transaction gets through as soon as you can, right? Now, there are some preventative techniques like commit reveal scheme and submarine send, but they are not like super popular. So you can still see a lot of front running attacks happening on especially NFTs and such, where a sell order for a particular NFT is placed, and then somebody is placed a buy order for that. And before it goes through, somebody else buys it, right? So front running is one of the common kind of attacks. And I would just say, like, make sure you have all things in check in your contract so that you don't get exposed to front running bots.